Are chemical changes faster in hot water or cold water? Before we answer this question, let's make sure that we understand what a chemical change is. And let's compare chemical change with a physical change. Let's start off by talking about physical changes. And imagine this piece of paper or paper towel here. If we crumple it up, we have changed its form. And this is a physical change. If we tear the piece of paper, like so, we have also changed its shape or its form. We have caused a physical change here. We have not changed the arrangement of atoms in the paper. Now, in a chemical change, atoms undergo a rearrangement. We can cause a chemical change to occur with this piece of paper by burning it. When we burn the paper, the atoms rearrange to give us new chemical substances. And that's the difference now between physical change and a chemical change. Now, let's come back to our original question. Are chemical changes faster in hot water or cold water? What we need is a chemical change that occurs in water. And it turns out that when Alka-Seltzer tablets are added to water, a chemical change occurs. The chemical substances in Alka-Seltzer undergo a chemical reaction. The atoms in the chemical substances of Alka-Seltzer are rearranged, and one of the products of the reaction is carbon dioxide gas. And we can actually see carbon dioxide gas bubbling from our chemical reaction. Okay, so that's the experimental design. Let's go ahead and carry it out. We're going to want to have a glass of hot water. And we will want to label our glasses because we are comparing two things. And we also want some cold water. And again, the glass is labeled cold. Now let's carry out our chemical reaction. We're going to add an Alka-Seltzer tablet to each glass of water, and let's observe the changes that take place. Is the chemical change that is occurring, is it occurring faster in hot water or is it occurring faster in cold water? Well, as you can see, the chemical change is occurring much faster in the hot water than in the cold water. The fizzing that you see and hear here is the carbon dioxide that is being produced. Notice in the hot water now the chemical change or chemical reaction is complete. In the cold water, our tablet is still reacting with the water, so our chemical change is still occurring. Why do chemical changes occur faster in hot water than in cold water? Well, in experiment 2, we learned that hot molecules move faster than cold molecules. For a chemical change to occur, for molecules or for atoms to rearrange, chemical particles like molecules have to collide. If molecules are hotter, they are moving faster, and more are going to collide, and our chemical change is going to occur faster. Why don't you repeat this experiment in your classroom and try to determine how much faster this chemical change occurs in hot water than in cold water. And why don't you try this experiment as well? Take a half a cup of cold water and a half a cup of hot water and mix them together, and add an Alka-Seltzer tablet to this mixture of water, and see if you can predict how long it will take for the chemical change to occur.